In this video, we're going to look at working with some indefinite integrals to find the family of functions that the integral represents. So for the first one, we're going to need a u sub, and we're going to let u equal 2 minus sine of x. So du is going to be equal to negative cosine of x dx. I don't want the negative there, so negative du is equal to cosine of x dx. So then this is going to give me the integral of 1 over u du. So this is negative ln of the absolute value of u plus c. So this is negative ln of the absolute value of 2 minus sine of x plus c. And that's it. Number 12, the integral of dx divided by the cube root of 3x plus 4. So here I'm going to let u equal 3x plus 4. So du is going to be equal to 3 dx. So 1/3 du is equal to dx. So this becomes the integral of 1/3 1 over u to the 1/3 du. So this is 1/3 the integral of u to the negative 1/3 du. When you integrate, you're going to get 1/3 times u to the 2/3. So then you need to multiply by 3/2 plus c. So you get 1/2 u to the 2/3 plus c. So you get 1/2, and then u is going to become 3x plus 4 to the 2/3 plus c. Number 13, we're going to let u equal t squared plus 5. So du is going to be 2t dt, but I only want a t, not 2t, so I multiply both sides by 1/2 t dt. Now I'm just going to use my u sub and rewrite this as the integral 1/2 times the integral of 1 over u du. So this becomes 1/2 ln absolute value of u plus c. And because t squared plus 5 can never be negative, this becomes 1/2 ln t squared plus 5 plus c with no absolute value bars. Now for number 14, 1 over theta squared times secant of 1 over theta times tangent of 1 over theta d theta. Well, this looks very complicated. It's actually not that bad. We're going to let u equal 1 over theta. So then du is going to be negative 1 over theta squared d theta. So notice I have that here and here. I multiply both sides by negative 1 to get negative du equals 1 over theta squared d theta. And I'm going to rewrite this as the integral of negative secant of u tangent of u du. And the integral of secant tangent is just secant. And then we put back the u. And that's it. Now for number 15. Tangent of ln of y all divided by y. I'm going to let u equal ln of y. So then du is equal to 1 over y dy. So this is going to become the integral of tangent of u du. And the integral of tangent is negative ln cosine of u plus c. And then I plug the u back and I get ln of cosine of ln of y plus c. Number 16, e to the x secant e to the x dx. I'm going to let u equal e to the x. So du is equal to e to the x dx. So this becomes the integral of secant of u du. And the integral of secant is ln, the absolute value of secant of u, plus tangent of u, plus c. So this becomes ln secant of e to the x plus tangent of e to the x plus c. Number 17, the integral of 1 over x ln of x dx. So here we're going to let u equal ln of x. So du is going to be 1 over x dx. So this becomes the integral of 1 over u du. So this becomes ln of the absolute value of u plus c. And then plugging back in u, we get ln of u. I'm sorry, ln of x plus c. And that's how you do integration with u subs and some trig functions.